Last week, a couple of big announcements in terms of all things AI. First one from Google DeepMind. They revealed Gemini. Gemini is a family of multimodal models that come in 3 different sizes. So the best way to get across to you all just how great this thing is, let's just jump into a video that they have put together that demonstrates the art of the possible here, art of the possible with their Gemini Ultra model. So let me play the clip here, and I'm going to use my judgment in terms of skipping some things here and there, but to get the point across in terms of what this multimodality looks like.
All right, testing Gemini. Here we go. Tell me what you see.
I see you placing a piece of paper on the table. I see a squiggly line.
What about now?
The contour lines are smooth and flowing, with no sharp angles or jagged edges. It looks like a bird to me.
What if I add this?
The bird is swimming in the water. It has a long neck and beak. It is a duck.
Yes.
A duck is a type of waterfowl in the family Anatidae. Ducks are closely related to geese and swans. The duck appears to be blue. This is not a common color for ducks. However, there are some breeds of blue ducks. These are typically not as common as other duck breeds. It is more common for ducks to be brown, black, or white.
Are you sure?
What the quack? I was just talking about a blue duck, and now you're holding one. It looks like blue ducks are more common than I thought.
Would this float?
I'm not sure what material it's made of, but it looks like it might be rubber or plastic.
What if I tell you it's making a squeaking sound?
Oh, if it's squeaking, it's definitely going to float.
Nice.
It is a rubber duck. It is made of a material that is less dense than water.
Can you teach me how to say this in a different language? And give me a few options. Ooh, can you explain?
You were trying to get me to find the paper ball under the cup. I accept the challenge. The cup to the left.
Nice.
I know what you're doing. You're playing rock, paper, scissors.
What do you see now?
The fingers are spread out to look like the wings of a butterfly.
What's this?
Big ear and barking mouth. A dog.
Sweet.
The coin should be under the right hand.
I don't know.
The coin is in the left hand, using a sleight of hand technique to make it appear as if the coin has disappeared. Both objects are round and flat.
There you go.
Both are food. The orange is a healthier choice than the cookie. Citrus can be calming, and so can the spin of the fidget toy. They are both examples of popular toys that have been enjoyed by children and adults alike for many years.
Give me some ideas for what I could make with this.
I see pink and green yarn. This is a picture of a crab.
That's right. Is this the right order?
No, the correct order is Sun, Earth, Saturn.
Based on their design, which of these would go faster?
The car on the right would be faster. It is more aerodynamic.
Which looks more fun?
The one on the right, because it has a loop.
What do you think this person might be saying?
How about a woohoo?
Ooh, I love that.
I see you're drawing a guitar. You've added an amp. Now it's an electric guitar. We can make some seriously loud music now. Given that you added drums, how about some 80s hair metal? Alright, I see you've added a palm tree to the drawing. Change it up with some beachy vibes.
What movie are they acting out here?
I think they are acting out the famous bullet time scene from The Matrix.
Ooh, nice. What do you think might happen next? Okay, I've got one more for you. Describe the drawing I made.
It is a simple line drawing of the constellation Gemini. You did a good job of capturing the beauty of Gemini.
Nice.
All right, so that's pretty cool. I mean, it's freakishly good, man. That's essentially a multimodal model in action, where it can take text, image, audio, video as input, and the output could be any one of those four things. So, all right, let's get back into, let me unpack for you what I have learned or read about Gemini so far. As I told you, it's a family of multimodal models that come in 3 different sizes. So let's get into that. So there are 3 sizes: Gemini Ultra, Gemini Pro, and Gemini Nano. Let me start with their largest and most capable model, Gemini Ultra, which is what was used to make those clips, make that clip that DeepMind had put together. It's using their Ultra model. And so the Gemini Ultra model has achieved state-of-the-art benchmarking and has surpassed GPT-4 across, I believe, 30 out of 32 benchmarks, which we will see soon. It's still Ultra is still under safety review according to DeepMind, but it will be available in early 2024 on a new version of Bard, and I think they're going to call it Bard Advanced. And then let's move on to the next model, Gemini Pro. In my opinion, it's comparable to GPT 3.5. What DeepMind is saying about Gemini Pro is that it's optimized for cost as well as latency. And as of December 6th, Gemini Pro is what's being used by Bard. And then on December 13th, Gemini Pro will be available to developers and enterprise customers of Google via a Gemini API in Google AI Studio or Google Vertex AI, Google Cloud Vertex AI, excuse me. And then Gemini Nano, their smallest model, and it's really meant for on-device tasks. So unlike Ultra and Pro, where we don't know the parameter count because they haven't disclosed it, Google did disclose the parameter count for Nano. And Nano comes in 2 different tiers. Nano 1 has 1.8 billion parameters, and Nano 2 has 3.25 billion parameters. And according to Google DeepMind, Gemini will also be available in many of their products and services like Search, Ads, Chrome, and Duet AI. One other item of note here is that Gemini, all of these models have a 32,000 context window, which is smaller than GPT-4 Turbo, which is 128,000 context window. And and I think Cloud 2 has believe 200,000 window. And so let's come in here and take a look at this. They talk about multimodality again here, and one of the things I want to highlight here is, so when I said it beat GPT-4 on 30 out of 32 benchmarks, the one that is mainly looked at, or people want to understand how a model did against massive multitask language understanding benchmark. And this is noteworthy that Gemini scored a 90, or Gemini Ultra, the largest model and most capable model, scored a 90% versus a human expert benchmark. So a human expert benchmark was set at 89.8, so it has been beat by Gemini Ultra. GPT-4 had scored an 86.4, which was slightly below the human expert benchmark. And it's worth pointing out, I think it's worth lingering a little bit on this thing here, massive multitask language understanding. It is a benchmark designed to measure knowledge acquired during pre-training by evaluating models exclusively in zero-shot and few-shot settings. And this benchmark covers 57 subjects, such as econometrics, electrical engineering, high school world history, logical fallacies, marketing, philosophy, etc. And so essentially the data set is it's a bunch of multiple choice questions that these models have to answer correctly. Obviously, here's where in the Gemini Ultra beat the human benchmark of 89.8% by coming in at 90%. It's just worth just highlighting this, that in June 2020, a fine-tuned GPT-3 model came in at 53.9%, and in 3 years now we got Gemini Ultra, which beats the human expert benchmark. So definitely worth noting that. And then here on this page, which I will leave a link to this and everything else that I've been showing you and will show you in the description, a link to all these items, so you can check it out for yourself. Here's all the other benchmarks that they highlight against GPT-4. So, and again, the 3 different sizes: Ultra, Pro, Nano, and anything to anything concept. It's just worth lingering on this as well. Gemini is a natively multimodal. Gemini is natively multimodal, which gives us, the users, the potential to transform any type of input into any type of output. So text giving audio, audio providing text, etc. This model it was pre-trained on all of those modalities: text, audio, image, video, and so it's able to do this. So I want to linger on this concept of natively multimodal. Essentially, up till now, multimodal models were built taking a certain approach, and I'm going to quote Demis Hassabis from DeepMind in the traditional approach, and I quote: "Until now, the standard approach to creating multimodal models involved training separate components for different modalities and then stitching them together to roughly mimic some of this functionality. These models can sometimes be good at performing certain tasks like describing images, but struggle with more conceptual and complex reasoning." End quote. And so their approach is different from that, not creating a bunch of different components and stitching them together. Their approach, and I quote him again, and I quote, "We designed Gemini to be natively multimodal, pre-trained from the start on different modalities. Then we fine-tuned it with additional multimodal data to further refine its effectiveness. This helps Gemini seamlessly understand and reason about all kinds of inputs from ground up, far better than existing multimodal models, and its capabilities are state-of-the-art in nearly every domain." End quote. This approach that they have taken, the approach of natively multimodal, it resembles, in my opinion, it resembles much more how we human beings or human brain learns from multisensory context, and that's what that video sort of displays when the person puts something down, the coin and the cookie. It picks up the fact that, hey, they're both round in shape, right? So that's what that was one of the key or newsworthy item past week in terms of AI. The second item that I want to share with you is what Apple revealed last week as well. Here's from Tech Republic. Apple offers developers MLX Framework for machine learning. It's this MLX Framework for machine learning, and according to the article, basically what it is, is a MLX is a set of tools for developers who are building AI models, including transformer language model training, large-scale text generation, etc. It was inspired by NumPy, PyTorch, etc., and it's available on both CPUs and GPUs, and it can run MLX on device, think iPhones, MLX on device without creating data copies. So I can tell you, this is definitely meant for where Apple wants developers to use this and deploy apps on Apple and through their App Store for AI related tasks. They point out that MLX's Python AI should be familiar to developers who already know how to use NumPy. So I think that's actually a really good thing, because you want this familiarity will get higher adoption rate for sure. The framework is intended to be user-friendly but still efficient to train and deploy models. The developers wrote on GitHub. And so, yeah, let's jump to GitHub and I'll show you a couple of things. So from their ML Explorer GitHub page here, and this is how one goes about using MLX. You can pip install MLX, but here are the conditions, and this first one is the most important one, because all across that article and in everything else I've read, they keep talking about MLX with your own Apple Silicon computer. Well, the primary requirement for using MLX is that you have an M series chip on your Mac device, and M1 or M2 chip, and that you have a Python version that's greater than or equal to 3.8, which could be easy. That's easy to fix if you don't have it. Mac OS greater than or equal to 13.3. Again, you just have to install the right version, although they highly recommend use Mac OS 14 Sonoma. All right, let me move on to their repository here. ML Explorer MLX. I'll leave a link to all of these things in the description again, so you can go check it out for yourself. A little bit about MLX again. It's an array framework for machine learning. These are all technical stuff. That's not my goal here to unpack technical stuff here. What it's designed by machine learning researchers for machine learning researchers. Okay, great. MLX examples repos. So let me go there, because I've already done some of these things already this weekend, and so here's some of their examples. MLX examples. The repo contains a variety of standalone. That's the key. Standalone examples using MLX framework. And again, this part of the video is meant for people who are already familiar with Python and machine learning, and using things like NumPy, PyTorch, TensorFlow, etc. And so if that's not your cup of tea, certainly click off and go check out another video. And so what I found interesting here is that not interesting. They say start with the MNIST example. It's a good starting point. But what I found really interesting here is some useful examples, including, and this is what interests me, transformer language model. So let's go there. And again, they keep noting, and I think it's really important, is that it's a standalone. Its only dependency is MLX. And this is an example of a decoder-only transformer language model. The only dependency is MLX. And I don't have to worry about this, but if you have a GPU, you would have to use this command. And there, by default, the data set they're using is PTB corpus, but you can choose, according to what they have to say here, you can choose any other data set. So let's quickly check out, check out the code. Copyright Apple, pretty cool. And all you would have to do is copy and paste this and play around for yourself. What I want to, I guess, here's my short little commentary on MLX here. The first thing I take away about this is the open source nature of this. And this is a significant departure from previous Apple frameworks. MLX is open source and available on GitHub. This is something completely brand new for Apple, and it's in a way welcoming when I see that OpenAI and DeepMind, they're going the other direction, much more closeness. With their Gemini model, there's not much there. They revealed some technical stuff, but it's not truly open source. So really, kudos to Apple. If this is the direction they're going to be going forward, being open source about things, I think it's great. The other thing I take away is that it's tailored for transformers. It's designed to work with transformer language models, which I think is great. And this should make it, MLX should make it an ideal choice for building applications like machine translation, text summarization, and even like chatbots on device, like on iPhone, I guess. But that's something that definitely it's in my mind. More with a friend of mine who has done development. He has deployed apps on App Store. Collaborate with him to see how this could be done. Those are a couple of points that I really find interesting. Again, the open source nature of this. I think it's fantastic that Apple's doing that. Hope you guys found this interesting and helpful. Until next time.